Welcome all, I am Divya RS from our Berzelius College of Engineering and Technology. In this session, I am going to deal with transposition ciphers. In cryptography, we commonly use the term ciphertext. So first of all, what a ciphertext is. A ciphertext is produced by encrypting a plain text using a key. So we can say a ciphertext is an encoded form of plain text. We have different types of classical cipher systems available. Some of the commonly used cipher systems are substitution ciphers and transposition ciphers. Now let us see what a transposition cipher is. A transposition cipher is a method of encryption. Here the encryption is done by changing the position or order of the characters in the plain text. That means you will just scramble the plain text letters. So a transposition cipher is obtained by just changing the order or position of the characters in the plain text. There will be no change in the or replacement of the characters in the plain text. That means you are not replacing the character, you are just changing the position or order of the characters in the plain text. So that is what you meant by a transposition cipher. Okay. Now let us see what are the different types of transposition ciphers. We have three different types of transposition ciphers, that is rail-fence cipher, columnar transposition ciphers, keyword columnar transposition ciphers. So first of all, what a rail-fence cipher is. A rail-fence cipher is obtained by writing the plain text downwards in different lines in a zigzag manner. Okay. So if you are asked to write or if you are asked to encrypt a plain text, then using a rail-fence cipher, then first of all what you have to do is you have to write that message or the plain text downwards in different lines in a zigzag manner. The number of lines is determined by the key size. The key size indicates in how many lines you have to write your plain text. Okay. After writing this plain text in a zigzag manner, the ciphertext is obtained by writing the message line by line. Okay, that is rail-fence ciphers. In rail-fence ciphers, you have to write the plain text downwards in a zigzag manner. After that, the ciphertext is obtained by writing the message line by line. Now let us see an example. So here in this example, your plain text or the message to be encrypted is "We are discovered, flee at once." And your key size is equal to 3. That means you have to write this plain text in 3 different lines. Okay. So you have to write this plain text in 3 different lines in a zigzag manner. So I have written this as W-E-A. That is W-E-A-R-A-D. That is a zigzag manner. Okay. This plain text have to be written in 3 lines in a zigzag pattern. Okay. And the plain text is obtained by writing this message line by line. Okay. First of all, you have to write the first line. Then you have to write the second line. Then it is followed by the third line. In this way, you will obtain the ciphertext. So that is rail-fence cipher. Okay. Your first line is W-R-I-O up to E. That will be the first line. Okay. Then the second line is double-A. Okay. Then the third line will start from AD. In this way, you have to write the ciphertext. So next is the columnar transposition ciphers. In columnar transposition ciphers, you have to write the plain text or the message in rows of fixed length. And the size of the row is determined by the key size. Again, the key size indicates the length of the row. That means how many letters should be included in each row. Okay. So here, what you are doing is, you have to write the message in rows of fixed length and then read out the message column by column. Okay, so that is the columnar transposition ciphers. Now let us see an example for this columnar transposition ciphers. So here, again your plain text is "We are discovered, flee at once." Okay, and this example, your key size is equal to 5. That means the number of characters or letters in each row should be 5. Okay. So each row should contain a maximum of 5 letters according to our key. So first of all, your plain text is divided into different rows, each row with 5 letters. Okay, and the ciphertext is obtained by reading this matrix column by column. Okay, so the ciphertext is obtained by, first of all, you have to write the first column, then it should be followed by the second column, then the third column, fourth column, and the fifth column. Okay, in this way you have to write the ciphertext. Okay, that is columnar transposition ciphers. You have to write it in rows, and each row should contain a letter, should have a fixed length, or the number of characters in each row is determined by the key size. And the ciphertext is obtained by reading it column by column. That is transposition ciphers. Then the last one is keyword columnar transposition ciphers. Here the order of the transcription is determined by the alphabetical order of the letters in the keyword. In the previous case, there was no such criteria for the order, but here the criteria is that the order in which the column have to be written is determined by the alphabetical order of the characters in the keyword. Okay, here instead of a key size, you are using a keyword as used, so that you can remember it very easily. For that, we are using a keyword as used here. So the alphabetical order of the characters in the keyword determines the order in which the transcription have to be performed. Okay, that is keyword columnar transposition ciphers. Now let us see an example. So here your keyword is zebra. Okay, zebra contains 5 letters, and the alphabetical order of the characters in this keyword is like 5. The first letter is the fifth one. 5, 3, 2, 4, 1 is the alphabetical order of the characters in the keyword in this example. Okay, so here the number of characters is 5. So again you have to write the rows with a maximum of 5 characters. Okay, your plain text have to be written in different rows, and each row should contain 5 characters since your keyword contains 5 letters. Okay, now what you have to do is you have to write the ciphertext. The ciphertext is obtained by writing or reading it out column by column. Okay, so here in this case, the last column of this matrix form the first one in the ciphertext. Okay, that means here your first, according to the alphabetical order of the keyword, the last column becomes the first one. Okay, so last column comes the first in the alphabetical order. So the last column have to be written first in the ciphertext. Then the second column, here the second column is the third matrix. Okay, right? So third column in the matrix will become the second one. So that will be the second one. It have to be written second. Then the third one have to be written. It should be followed by the third column, then fourth and the fifth one. Okay, this way you have to write the ciphertext. So that is keyword columnar transposition ciphers. Okay, that means here the order is determined by the alphabetical order of the characters in the plain text. Okay, so as a conclusion, we can conclude that a transposition cipher is a cipher that produces a ciphertext by changing the position or order of the characters in the plain text. That means here we are not changing the characters in the plain text, we are just changing the order of the characters in the plain text. And we have 3 types of ciphers available, that is rail fence, columnar transposition, and keyword columnar transposition ciphers. And among these 3 ciphers, we are commonly using a columnar transposition ciphers. Okay. So by this, my session is over. Thank you.